Welcome to viewers and students. Here we will start the basic concepts of geometry. Means we will start with point, line segment, line, etc. Now if we go back to the history of the origin of geometry, you will come to know that the word geometry is coming from two Greek words, geo and metron. Geo means art and metron means measurement. So geometry means measurement of the art. The concepts of geometry were used even before the birth of Christ. There is something called the shore of Egypt. The river Nile is called the shore of Egypt. Every year during the time of flooding, the land boundaries were wiped out due to deposition of soil over it. So farmers had to find out the boundaries again. So they tried to use geometrical techniques for redrawing the boundaries. Similarly, geometrical ideas were used for making palaces, roads, buildings, etc. in ancient times. So we'll start with point here now. So what is actually a point? Point, it refers to a position. What is point? It refers to a position. It refers to a position on the surface, position on the earth. Say for example, when we say the North Pole and South Pole, you remember the axis of the earth. The axis of the earth ends at these 2 points. One is called South Pole and one is called North Pole. This is the equator. So the end points of the axis of the earth, these are called poles. This is North Pole and this is South Pole. So this point refers to the North Pole and this refers to the South Pole. Similarly, every point on the earth surface, if you draw a latitude, then if you draw one, this is longitude, and if you draw a parallels of latitude like this, then you find the point of intersection of latitude and longitude. So this point also refers to a position on the earth surface. So what is point? It refers to a position. Suppose you make a dot on the white page. Now this is point, say it is A. Make another point, suppose this is B. It is more visible, right? Similarly, point C, it is even smaller than A. It is smaller than A. So what is the actual size of point? Is there any size or dimension of a point? No, point has no dimension, it has no length or breadth. So the size of the point is, it is as small as you can imagine, right? You just make a sharp dot with the help of your pencil or pen on the white page. So it refers to a point. So it is D. So point has no length or breadth, no thickness, right? So point has no dimension. You cannot find length or breadth of a point, no thickness, right? So point has no dimension. The size of the point is as small as you can imagine. Now, point is the building block of a line. It is the building block of a surface. Suppose you make too many, suppose this is a point. Now you make too many points around it. Too many points. So what you will get after making such points? You will get a surface. It's a plane surface, right? So if you make too many points surrounding a point, finally you got a surface. Now if you make too many points on the surface of a, say for example, round object, say on the surface of an football, then what you will get? You will get a curved surface. If you make too many points surrounding a point on the football, you will get a curved surface, right? Here it is plain surface, is a white paper. On the white paper you are making too many points surrounding a point, so you got a plane surface. So plane surface is actually, it's a collection of point. So now point is the building block of the surface, tiniest unit of the surface. So you can say point is the tiniest unit of a surface. Now let us imagine 2 points here. One is, say, it is A, and this is, say, it is B. Now let us join these 2 points with the help of ruler. Right? You are joining 2 points with the help of ruler. So what you got? It's a line segment. So what is a line segment? It's a straight line joining any 2 points. It's a part of a line actually. If you extend this line segment on either side infinity, if you extend this to infinity, now there is no space here, we'll mark as arrow mark here. That means this line is extended to infinity on both sides. So this is called straight line or line. That means a line segment is a part of a line. So if you cut this line in B and C, that means BC, we write it as BC. It's a line segment. Similarly, AB, we write it as AB line segment. This symbol is line segment. So line has infinite length. We cannot find the length of a line, but line segment has definite length, right? Line is extended to infinity on both sides, but segment has a definite length. Right? So line segment has definite length, but line has, you cannot find the length of a line. It is extended to infinity on both sides. Now let us imagine a point. Suppose this is A. Now you draw a line, suppose, from this point and extend this to infinity on the right side. We are extending this line from this point A, and this is extended to infinity only in one side. This is called ray. So a ray is starting with A. Suppose you imagine another point, suppose B. Now the line segment AB is extended to infinity on towards right side. We write it as AB ray, ray AB. Similarly, this is suppose another point D, and this is C. Now let us join these 2 points D and C. Now let us extend this line segment towards D to infinity. So you got a ray, another ray. This is written as CD. CD. It is extended to infinity towards D. This is written as CD. This ray is written as AB. A is the starting point, so you should write it at first, and B is towards the infinity side, towards which ray is extended to infinity. So B is the second alphabet. Here the ray is starting with C, so first alphabet is C. We'll write it as CD. Now let us talk about Curve. What is a curve? It might be a closed figure and it might be an open figure. So it is called open curve. This is called closed curve. Closed curve. It's a closed figure obtained by joining points. It is called closed curve. It is called open curve. Open curve. Right? Now this region, the surface within this closed curve is called a region. We call the shaded portion is as region. Right? So you can draw closed curve like this. This is closed curve, and whereas this is open curve. Open curve. This is closed curve. Closed curve. Right? Now we'll discuss about polygon. Now let us draw a closed curve obtained by joining straight line, closed figure. This is, let us join these points obtained by joining line segments. Now this is called polygon, right? It's a closed figure obtained by joining line segments, right? So polygon is a closed figure obtained by joining line segments. Similarly, a triangle, you are joining 3 line segments. Square, suppose square, then rectangle, right, or any quadrilateral. These are together, these are called polygon, right? So closed figure obtained by joining line segments are called polygon. This is triangle, quadrilateral, 4 sides. Then if you got 5 sides, we call it pentagon. Hexagon if it is with 6 sides. So together they are called, generally they are called polygon. Next we will discuss angle. Now let us make 2 rays from this point. Suppose this is point A. Now you make 2 rays starting with A. One is, say, this is B, ray AB. Then another ray you make, suppose this is C. Right? Now this figure is called angle. Angle is obtained this corner. You got a corner here. We name it as angle. And it is named as angle BAC, or it is named as CAB. So when you make 2 rays starting with the same point, you obtain an angle. Angle is named in three alphabet. This point is called, middle point is called vertex. So this is called vertex. And these 2 are called arms. Arm. This is also called arm. Right? So there are 2 arms and 1 vertex of the angle. Now we will discuss about uh, parallel lines. Parallel lines. Now let us imagine these two lines. These two lines, we name it L, suppose. This line is suppose M. Now you see, these two lines will never intersect each other. They are equidistant. Like equidistant. Suppose this is A, B, C, D. Now if you find it, this distance between these two lines, perpendicular distance, it is same everywhere. That means if you draw perpendicular here, numerous perpendiculars here, then you find that all these are equal. So these lines are called parallel lines. So what is meant by parallel lines? The lines which never intersect each other, even if they are extended to infinity, they are called parallel lines. So these two lines, even if they are extended to infinity, they will never intersect each other. So what is intersecting lines? Intersecting lines means these are called intersecting lines. Suppose they have a common point. Intersecting line means they are passing through a common points. You can make too many intersecting lines. Infinitely many lines through a point. So these are called intersecting lines, and these are called parallel. These are called intersecting lines. Right? So parallel lines will never meet each other, they will never intersect each other, even if they are extended to infinity. Intersecting line means when you draw two or more lines through a common point, they are called intersecting lines. Now line L is parallel to M, so we symbolically we write it as L parallel to M. This is the symbol of parallel. Similarly, you can write AB is parallel to CD. Line segment AB is parallel to CD. Suppose we write it as parallel symbol as this. Now this line, suppose L, M, M. Now line M is not parallel to M here, so we write it as not parallel to M. Similarly, line L is not parallel to M. Not parallel. Cross the parallel symbol. They are not parallel. Now let us do one exercise from Cbse curriculum. Suppose you are given this line. This point is O. There are two rays here. This is C, and this ray, this point is B. This is E. This point is suppose D. Make us another ray here. Now from this figure, using this figure, name 5 points on this figure. 5 points in the figure. Can you name 5 points in this figure? Yes. The points are D, E, O, B, similarly C. These are called points from this figure. They are on the line DB, or the point O and C, they are under a OC. Right? Can you name the line here. Yes, we can name the line here. dB is the line. dB is a line. It is extended to infinity. You can write it as a dB line. Can you name 4 rays from this figure? 4 rays. Let us name this as, suppose, F. Can you name 4 rays here? Yes, one can be OC, it is 1 ray. OB is 1 ray. OF is 1 ray. Similarly, OD is another ray. So these are rays. Can you name five line segments from this figure? 5 line segments. These are rays. Right? Now, line segments. Can you name some line segments from this figure? Yes, you can write it as DE. This is line segment. We write it as this DE. EO is also a line segment. Then OB is also a line segment. Similarly, DO. This is also a part of this line segment. Similarly, EB. This is also a part of this line, so it is called line segment. Now, next question is suppose you are given this line and there are some points here A, B, C and D. Now can we name this line in different ways? How can you name this line in different ways? Now let us come to the definition of a line. What is a line? When a line segment is extended to infinity on either side, we call it a line. So you can name it as AB, line, right? Or you can name this as line BC. If you extend line segment BC on either side, left and right, you will got this line. So I say this line is denoted by L. So BC refers to this line L. Similarly, CD refers to the line L. Similarly, we can name it as AC or AD. Similarly, how can you name this line as, you can also name it as BD. You can name it as BD. BD also refers to this line. You can also name it as DA, same thing. DB, same thing. DC, same thing. You can also name it as CA, CB. So how many ways? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If there is another possible BA, BA is already written, not yet. You can write it as BA also. So you can name this line 12 different ways. These are the 12 different ways you can name this line L. Right? Thank you, viewers. We will discuss similar exercise in next class. Bye bye.